All right, today we're doing lesson 2-6, add and subtract decimals. So on 2 days ago, we did the adding decimals. Yesterday, we did the subtracting decimals. And today, we're going to do both, add and subtract decimals. Julie and the solve and share. Julie and Paolo are building a treehouse. Julie has a wood board that is 1 15 hundredths of a meter long, and Paolo has a board that is 7/10 of a meter long. What is the total length of the two boards? Solve this any way you choose. How can you use a model to help solve the problem? So we're trying to find the total length. We got to remember we're going to be looking for total, so that's an adding. And we can use our use a model by doing we can use a grid, the 100 block, or we can use a bar diagram. I kind of like the bar diagram better. It's easier to draw. So for a bar diagram, I would say I don't know what the total is, but I know one of the values is 1.15 and the other value is 0.7. So that would be using a model. And to find the answer, I use the algorithm. And remember, I'm going to have to do some annexing zeros. You might want to throw one in the front there to help you out too. Add them. So I can say x equals 1.85. That will be our total. So that is the way I'd choose to do it. If you use the number grid, that's fine. You got to have a number grid on hand, and they're not always handy. The 100 grid. So I liked using that, using the bar diagram. So how much longer is one board than the other? Use a bar diagram, which we just did. So, all right, how can you add or subtract decimals? Kim and Martin swam 50 meters. Martin took 26 of 100 second longer than Kim. What was Martin's time in the race? So if needed, annex a zero so that each place has a digit. So Kim and Martin swam 50 meters. Martin took 2600 second longer than Kim, and Kim's time is way over here, kind of hidden over there. So we take Kim's time, and we're going to add the additional time it took Martin to find the total time it took for Kim. So we are finding the sum and adding them together. In another race, Martin, in another race, Martin's time was 53.2 seconds and Kim was 51.79. How much faster was Kim's time? So in this case, we're going to do subtraction. And we're going to have to, got that little blobby thing there, sorry. We're going to be annexing a zero. So we can do some subtraction. Oops. And we borrowed from over here. You know what? I'm going to rewrite that one because that was super sloppy. All right, let me do that again. So we have 53.2 and 51.79. I'm going to annex my zero, and now I can subtract. That looks a little bit better. And I had to borrow. I'm going to have to borrow again, regroup. Here we go. So 1.41 and okay. And making sense and persevere. Perseverance in math is when you stick with something and finish it. Now, we really know there's a lot of things in math that we need to work hard at to figure out. And from the time you were little, things have been difficult, but then you learn them. It was hard to learn how to count when you were really little, but now you can all do that. So perseverance does pay off. You will gain quickness, speed, and accuracy, and you'll gain some stamina in math. And you think about things in a different way, you'll learn how to solve them. In a race the next day, Kim's time was 51.7 seconds. Martin's time was 79 hundredths of a second slower than Kim. Estimate Martin's time and then find his exact time. So Kim's time was 51.7 and Martin was 79 hundredths slower than Kim. So let's figure out what Martin's time was. So this was Kim. And this is Martin. So that's his exact time. And his estimated time, I would say Kim at 51.7, she rounds to about 52. And Martin is 79 hundredths of a second. That rounds to about 1. So I would say their estimated time would be 51 seconds, and my actual time came out very close to that. So that's doing two models, using the estimation model and finding the actual answer. And that my estimation makes sense and my actual answer makes sense when I compare them. Okay, a little bit more here. And generalizing. How are adding and subtracting decimals similar and different from adding and subtracting whole numbers? How are they similar? Adding and subtracting are the same. We line up the decimals. In decimals, we line up the whole number values in whole numbers. So we line up by place value. That's definitely the same. Lining up by place value. And the difference would be in a decimal value, we have a decimal in there. That's the only difference, is we're including a decimal along with our place value. Describe how you know whether to add or subtract to solve a decimal problem. Wow, that's really tricky. Well, you're going to use addition when you want to combine. So when we want to add, we're combining values, and that's one of the words you might see in a word problem. There's other words that might help, and you subtract when you want to compare values, or if you need to take something away from something. And it could be a lot of different words that will clue you in to whether you're going to be adding or subtracting. So find each sum or difference. Make sure you're watching the sign. Sometimes I tell kids to just double check, okay, we're adding here. Make sure you're checking in with yourself. All right, I'm adding 9 plus 7 is 16. Carry the 1. 5 plus 1 is 6 plus 2 is 8. And don't forget your decimals. In this case, we're subtracting. So I can't take 5 away from 1. I'm going to have to borrow all the way over at the 4. Make that a 10. Borrow from that, make it a 9. And now I've got 11. So 11 minus 5 is 6. 9 minus 9 is 0. 3 minus 2 is 1. And for number 5, and so on, you're going to really need to write it off page probably. And make sure you are rewriting your right sign, annexing your zeros if you need to. Oops, that's supposed to be a 7. Okay, so 7. Let me get that cleaned up a little bit. Here we go. All right, that's better. 7 plus 5 is 12. Carry the 1. 7 plus 2 is 9. Plus 1 is 10. Don't forget our decimal. Number 6, 1.5 minus 1.05, going to the hundredths place, so I'm going to annex a 0 here. I can't take 5 away from nothing, so I'm going to regroup, borrow, subtract. 1 from 1 is 0. Number 7, 10 plus 3.28. For this one, I'm going to annex 2 zeros and a decimal point, because remember there's a decimal after every whole number. Some of you might have been able to do that one right in your head. Number 8, 15.00 minus 6.01. And I put those zeros because I knew that the number I was going to subtract out went to the hundredths place. So I knew I needed to add 2 more zeros. I'm going to do a lot of regrouping here. So 10 minus 1 is 9. 9 minus 0 is 9. I can't take 6 away from 4. So 6 away from 14. What am I on? Number 8. Yep. 8.99. And number 9, 3.45 minus 1.6. I'm going to annex a 0. 5 minus 0 is 5. I can't take 6 away from 4. 14 minus 6 is 8. 2 minus 1 is 1. And number 10, 9.12 plus 2.06. Starting in the hundredths place, I'm adding on this one 8, 1, and 11. Here we go. And then you can work on your independent practice and the word problem page. Especially take special attention, taking a look at let me hop over here. If you can always just do some of the page. If you feel pretty comfortable on the concepts and you want to just hop over to the word problems because they're a little trickier. And those of you that remember your topic 1 math tests, it's the applied math that's always a little tricky. And if you go to the bottom of the problem solving page, there's always a couple problems that are very, very similar to what you see in the test. So these are really great places to practice for your topic tests. And these, you need to have some perseverance and stamina. There's always a lot of extra work to do on these. In this case, you're going to have to choose all expressions that are equal to 3.89. So you're really going to have to solve all of these. You might be able to get away with estimating on some of them. Like, for instance, the second value here, 48.5 minus 9, you know that's going to be way bigger than 3.89. So you could just cross that one off right away because you know it's not going to be a possibility. You can just get rid of that one. 3.89 is around 4. So 16 minus 12, my answer is going to be close to 4. So I'm probably going to have to check that one. 4 minus 0.12, that could be close. 128 minus 124, that could be close to 4. And 6 minus 3 could be close to 4. So we only got rid of one of them there. So you're going to have to solve all of these problems separately and then shade in the one that fits. Let me just make sure I'm not looking like that's shaded in because it's not shaded in. Come on, computer. Very laggy. There we go. On this next one, on 31, choose all of the addition problems in which you annex zeros to align values in the addends. So when are we going to have to annex zeros? That one's not as hard. We can actually go through and do that one just by visual. We're going to have to add some zeros to this one, to the 4. We're going to have to add some zeros to the 12. We won't have to add any zeros here because there's 2 digits in decimal place value in both values. There's 1 digit in decimal place value in both values there, so we won't have to annex any zeros, and we'll have to annex zeros on the last one because there's 2 digits in place value on the last add-in, none on the second one, and 1 on the first. So we're going to need to go to 2 digits. We'll have to do a lot of adding of zeros. So I actually didn't even have to do math on that one. I'm just using my number sense for number 31. Number 30, you have to do some math. So if you're going to just do the book work or just do the buddy work, it's still a good idea to take a look at the Common Core assessment review items because they're very, very similar to your testing items on your tests. All right, have a great day.